In this video we're going to be covering inputting lab information for the example roadway project. So since we've input our driller input into the example roadway project, we can go ahead and start inputting our soil lab information. So first I'm going to open up in the soils lab input the example roadway project, the raw lab data. So I'm going to open that up. So the first sheet in the example roadway raw lab data is our profile extrusion log. And so basically this is a summation of the profile holes and the samples that are associated with those holes. So for instance, this first cut profile hole, hole number 1, had a bag number, number 2 that was collected, and then had 3 jar samples. You can go down through here and see which what type of hole the hole was, whether it was cut profile or fill profile, and it has jar and bag samples associated with that. Then also on the right here, it has a lab ID value that's given to that particular bag sample. And so the next sheet is an extrusion log, and so that keeps track of samples that were taken in the field that are either split spoon or Shelby tubes. So for hole 6 here, there was a split spoon taken, and then hole 7 was a Shelby tube. And then the classification lab ID that was given to those two are shown here. So your next sheet is just a summation of the bag samples. So there was 2 cut profile bags collected, and the hole 1, it has station and offset for that particular sample and has their lab ID here. So there's 2 cut profiles for this example and then 1 fill profile. The next 2 sheets are moisture contents for the jar samples. So hole 1, jar number 1, and then you have your wet weight, your dry weight, and your tear. After that is your lab classification forms, and you have your lab ID up at the top. And then you have 2 sheets of your proctor data. And your last 2 sheets have proctor data with your CBR value for that particular sample. So we'll get into inputting this information. And so I'm just going to be going over 1 cut profile bag and then 1 fill bag and the entry for that those particular 2 bags. So I'll push this to the side and open up my gINT example roadway project. Lab testing, and for hole number 1. And so you can see as we were inputting the driller information, this soil specimen table was being populated with information because we put there was a cut bag on that first profile hole. It already input your sample number, has jar information, so that all that is ready to be input. Okay. There was no description attached to these profiles. This bag sample here. So I'm going to go through inputting the information for this cut bag. It's hole number 1, and then the jar information. And so we'll go ahead and what we need to know is for the cut bag, the sieve, what type of sieve was conducted. And so I'm going to go find that information. So our lab classification number was 1024. So 1024 here. And this top right section here gives information on the gravel portion and whether it was mechanically sieved. You can see there's values here, so it was mechanically sieved. And so we'll go ahead and put with gravel here and hit save. And so that'll start inputting some default values into the sieve table here. Okay, moving on. For natural moisture content, Cut bags are actually, the natural moisture content is an average of the jar samples that are taken for that hole, the protocol that we use. So we'll go up to natural moisture contents, and you can see you have your hole specified and then your jar sample. And so we have our wet weight, our dry weight, and our tear. So we'll input that, 792, 18, 287.9. Save. Go on to the next jar sample. So that's 775.9. Zoom in a little bit. $704.3 and 288.1. We'll go ahead and input our last jar sample. And that's jar number 3 for hole number 1. So 743.1, 634.9, and 287.9. Hit save. And so this natural moisture content here is an average of these 3. Okay. So now we have that information. We'll go ahead and go to our Atterberg information. And there's no Atterberg information for the jar samples, but there is Atterberg information for that cut bag. So to get to that information on our sheet here, and we'll go back, and this is hole number 1, cut profile. And so the lab ID value that was given to the sample for classification is 1024. So we'll go down to 1024, which is this one. And this is basically the same input as we did for the classification values given in the example structure project. So we'll start inputting this information. So for our liquid limit data point, we have 33.18. Dry soil is 27.34, 13.98, and 23. Number of blows, and then our plastic limit information is given here. So we have 18.27, 17.55, and 14.13. And if we leave off the number of blows here, it knows it's a plastic limit point. When we hit save, it calculates the liquid limit data. Okay, so now we'll go ahead and start inputting our sieve information. So our weight of our total here is on our mechanical sieve analysis, so that's 1157. Weight of our fines tested here in the Kentucky Geotechnical Lab, the weight of fines tested is always 50 grams. And so we'll input our water content of our fine material, which is our hygroscopic moisture right here. And 29.6. And now we need to input our information for our mechanical sieve data. So we need to have a sieve that has 100% passing, which is the 3/4, and then our next sieve is 17 at the 3/8, number 4 is 6, and number 10 is 8. And then our sieve analysis for our fine aggregate here for the number 40 is 0.69, and then number 200 is 2.54. So we'll hit save. So those percentages are calculated, and we'll move on to our specific gravity. And so this was for depth at 0. Our specific gravity information is here, so 72. I'll blow that up a little bit more. 72 is our temperature. Weight of our sample is 28.33, 156.81, and 174.74. We'll hit save, and then that'll push information into the hydrometer table. So there's our specific gravity. And then a hydrometer ID, as I mentioned in the example structure project, this field is coming from a lookup table inside the library file. And so if you want to input information so that it'll automatically populate the calibration factors for a particular hydrometer, you need to go into this hydrometer calibrations table inside the library file and input that information. So we're going to use gINT 707901, and we'll save that, and it puts in our calibration factors, and then now we can put in our hydrometer information. So 2 minutes, reading was 47, and temp was 67. 60 minutes was 29. It stayed at 67. At 250 minutes, it was 24 and 68 degrees, and 1,440 minutes was 20 and 67. So we'll hit save. We'll populate our particle size, and now we have our soil classification for our bag sample. And so that's for the cut profile. Okay, and so cut profiles, those bags also get proctor tests and CBR tests conducted on them. So I'm going to go ahead and input our information for the proctor test for that bag, and then the CBR data for that bag. So we're going to proctor. Go to the very top again. So our bag, cut bag for hole 1, the lab ID was 1024. You see here 1024, cut bag. We'll go down to 1024 here, which has information on the proctor data and then our CBR information. And so we're going to input here our proctor data. And so we'll select our method, which was 1029A. Our mold diameter is on here. Mold diameter is 4. And then our mold height is 4.584. And our mold volume will be calculated. We'll hit save this so stuff will get populated. 29 inches. Our mold weight is right here. So 4246. Weight units is grams. That should be good here. Let's save. And now we'll start inputting our information for our compaction points. And so you can see here we have our wet weight, our wet soil plus our dish, our dry soil plus our dish, and then just our dish weight. And so with those values, you need to input them all at once, so that you can then use that to calculate your maximum dry unit weight and your optimum moisture content. And so it's 6,021, 142.5, 129.3, and our dish weight was 33.5. Our water content, our wet density, and our dry density will be calculated. 169.5, 149.8, and 32.1. 6146, 151, 132.5, and 32.9. 6114, 162.1 and 139.4. Our water dish weight was 33.1. Okay, when we hit save, our water content, our wet density, dry density are calculated, and then our maximum dry unit weight and our optimum moisture content was calculated. And so that's how to input the proctor information. And so now we'll input our CBR information. Okay, so we need to input our depth, which was 0 for that bag sample. There was 0% above the number 4 when this was tested. Our dish weight for a CBR test is 154.3. Our dish weight 148.6. Dry weight was 32.6. Our moisture is 4.9. Our CBR is 1.2. Our air dry soil was 4134. Our water was 508. And our rock was 0. Hit save. And all that information is stored for our CBR information, and that's inputting all of the soil classification, the jar, moisture contents, and the proctor and the CBR data for a cut profile bag. And so the next sample that we need to input information into you have some jar samples here, which is pretty simple. You just need to read them off. The data here, data right here. So you have your hole 2 and jar number 1, jar number 2. So you can input those. It's your natural moisture contents. The next bag sample is here for hole 3. And to double check if that was actually the hole that bag sample was sampled from, you can go back to driller forms, profile holes, and you can see here for hole number 3 that bag 1 was sampled from there. It's just not a reference. So you need to input information that we just input for that particular cut bag, which is your natural moisture, Atterberg, sieve, specific gravity, all that stuff. I'll go ahead and skip through that because it's the same as what we just did, and then I'll skip to the final sample. Okay, so now I've input the information for all the samples up to hole number 5, and so I'm going to start inputting information now for the fill bag. So basically this is the same as the last 2 cut bags, except the fill bag does not have proctor information or CBR information. So we'll go ahead and start inputting our natural moisture contents. And so go to hole 5. So this is the moisture content information for the jars. So we have jar at 2.5 feet down. Our wet weight was 964.6. 845.9. Our tear weight was 287.9. And input R 7 feet down, 7.5 feet down. Sample is 951.3, 828.2, and 287.3. Hit save, and you can see the average value for the fill bag was populated. So moving on to our Atterbergs for the fill bag, and that is associated with hole 5 fill bag, item ID 1026, which is this one. So we'll start inputting our liquid limit data. Select our 0 depth. It's 32.38, 28.75, and 14.16. 23 blows. Next one is 20.85, 19.70, and 13.92. populates our Atterberg information. We have our sieve data, and so I forgot to add that in our soil specimens. But we can do that here. We can see there's no gravel attached to it, so we'll go over here and specify no gravel and hit save. And then our defaults were put into our sieve. So this placeholder was put here because there's no information for total amount for mechanical analysis. So we can input our 50 grams that were tested for our fine aggregate and input our hydroscopic moisture. It's 33.39 and 32.91. And we can input our information. We saw above that there was no percent passing the number 10. Number 40 was 0.39. Number 200 was 13.75. Save. Calculates those percentages. Move on to specific gravity. That's here. So 72 degrees. 32.84. 155.75. And 175.88. Hit save. Push the information to hydrometer, so we have our specific gravity. We'll select that, hit save. Here's our default calibration factors. And input our specific our hydrometer analysis information. $15.68 and 250, 13.69 and 1,440. Oh, 1,440. Typed it wrong. 11 and temperature was 69. 69. Hit save. Gives our particle size, and so now we have our soil classification for our fill profile bag. So silty clay with sand. We don't have Proctor or CBR data, so that's all of that information. And so what's left now is to input information for the split spoons classifications that were conducted, and that's on this extrusion log. So we have our split spoon for hole 6, and then our Shelby tube for hole 1. So that information is the same basically as inputting information for any other type of Shelby tube or split spoon, and that was covered in the example structure project. So if you need to see how that information is input, go back to the example structure project. And so now I'm going to fast forward past that data entry. Okay, so now I have the soil input for the samples here. For hole 6 and hole 7, which were a split spoon and a Shelby tube. And again, if you need to see an example of inputting that specific type of data, go ahead and go to the lab input for the example structure project, and it has that walkthrough. And so now I've input all of my lab data for the example roadway project. And so now I want to basically just show you a few of the outputs. So we'll go to output, and first one I want to show you is profile extrusion log. So that's in graphic tables and Kentucky profile extrusion log. I'll go ahead and exit out of this raw lab data. So preview it with the eyeball, and there's our profile extrusion log. It has information for our hole, our jar numbers, our depths, and that's useful for when samples have just came in and you want to print out a sheet with it of the information on those samples from inside of gINT. And also the next one I want to show is the Proctor graph. And so that's in graphs and Kentucky Proctor, and we'll preview that with the eyeball. And this is the two graphs for the two cut profile bags, for the two cut profile bags. So you can see your information for that. Awesome. So I hope that helped. That's all the lab input for the example roadway project. Thanks.